So hello and welcome to my next tutorial for master design and research projects. Since I recognized in the last 2 years that there are a lot of doubts how to implement MRP, and the MRP is delayed in most of the project until there is too less time to implement it. And then there are only two options. The project is a fail, or the project has to be extended. And since I don't want those fails or extensions in future, I'm going to show you at least how MRP can be implemented in Anylogic. So this is just a very basic and draft what I show you, and some of or most of the things are still hard coded, yeah, so you have to extend that, but it should show you that it is not on the level what we had in simulation of logistic systems. You have to use those knowledge in terms of the methods we have applied, so the MRP, the hierarchical planning, and the software, Anylogic, and then use that as a starting base, as a foundation, and from there on you can master your graduation project. So, and for that we have to generate a very simple example. So let me switch to one of the lecture slides. We have to generate bill of material based on the technological restrictions. So we need engineering bill of materials. We need to develop our MRP bill of material. So perhaps we just take item A. So we are producing item A. We assume we need 1 X and 2 Y. And the assumption here is already Y is always available. That implies we do not need to calculate production orders based on the MRP algorithm. We can just make sure in the simulation that Y is available. Of course, you can extend that and argue you have to purchase Y and use MRP to calculate the purchasing orders. And we also have set. And to assemble set or generate set, all the raw material is available, and that's the reason why it's not available in this assumption. Yeah, so we need, for instance, 3 items which are processed on 2 machines. Yeah, so the finalization, so the assembly procedure of item A with the child item X and Y are done on machine 1. And to produce an X where 1 set is needed is done on machine 2. And in this beautiful tutorial, I just want to show you how to identify cross requirements for one item. So what we are going to do in this tutorial, we generate 1 customer order. And based on this customer order, we are calculating the cross requirements. Yeah. So that means we are not touching the rest of the MRP, which is the netting, lot sizing, backward scheduling, and the bill of material explosion. That's then your duty in the case you're implementing MRP. So, and for that we start with an empty model. We generate a new model, model 2. We will be selected in days. Where are you? Finish. So then process modeling library. We generate an custom order by the sync. We immediately go to an match block. And then we delete what's coming out. I mean, here nothing maybe can come out. So, and then we have to generate the cross requirements. So for that, I go to the agent library, I select a variable, I name it cross requirements. So that is then not a double type. I make an array out of it so that that becomes a metric. So top and no, not like this, but like this. And then I'm also going to initialize it, new double. Then again, this beautiful brackets. And here you are. Then we initialize it. We make a planning horizon for 1 week. So 1, 2, 3, 4, 5, 6, 7, and 8. So then the first period is perhaps backlog, and then we have 7 remaining days. Since we have 3 products, I copy this vector. So this one is responsible for item A. This is item, what was it, X, and that was Y. So I have to close that. And we have to make a semicolon, yeah? So we can debug it immediately. We see we do not have any mistakes. So then I want to generate one customer order just for testing purpose. So I select an event. The event is called event generate customer order. I call that event occurs once, so the mode is occurs once at time 0. And the action is a simple action, source, inject, control space, inject. I want to inject one order. Good. So that means I have to change the source from rate to calls of inject function. Since I want to give a due date to the order, I have to make sure to generate a new agent. So new agent, there is an order. So hello order. As I told you, I want to have a due date here. So this is parameter due date. Double is fine with me. So we have now to change from agent to order, and here as well order. And since we just have one order, and that should be just an example how to make an test customer order, I give the information to the order in the agent dot parameter due date, and that should be set to 7. So what I'm doing here, at time 0, I generate an order with a due date of 7. So 7 days is the customer required lead time, and this order is waiting here in the match block. So let me see what we can see if I run. It's compiled. Here we are. Here the order arrives at time 0, and then it's waiting. And now we want to execute the MRP already. For that, I generate a new event, which is called, I don't know, MRP, event MRP. This again is not occurs once. This is then a cyclic event because I want to execute the MRP, for instance, every day. The first occurrence is time 0, a recurrence time is 1. And here you can write already the MRP code, yeah? Cross requirements. The cross requirements, so are the open orders. They're waiting, in my case, in the match block in Q1. So, and of course, the MRP should only be triggered if there are waiting orders. Yeah? So I make sure with an if statement, if the match Q1 dot size is greater than 0. If that is the case, then we start with the MRP logic. So I still have issues with my English keyboard. And now we have to see how many orders are waiting. Yeah. If there are 10 orders waiting, then we have to do this calculation of the cross requirements for all those 10 orders. Yeah? So that means we need a for loop, integer e equals 0. E is smaller than the amount of orders waiting in this queue. This is match.q1.size again, and e++. So, dear for loop, so now we're there. This is the for loop. Where do we want to store the information? The information should go to the cross requirements, which is an array. And now we need to define the position. So I hard coded now. So I am just interested in item A. Yeah, so you could also produce or have custom orders for item B. You have to make sure that you select the correct one. Yeah? And hard coding is never a good option. Yeah? Since I'm not giving my order agent any attributes regarding the prod type, I hard coded it here. Yeah, but that's in future your duty. Based on bill of materials, based on distributions, the different types of orders can be generated. And now we need the position where this order, this cross requirement is due. We set already the due date here in the order in the source. So it's in the parameter due date. So each agent is, we know the due date. That means we go to the position of the due date. So the due date is stored in the first order waiting in the match block, which is in the match q1.get, and the get function returns the position I indicate here in the attribute of my get function. So I'm interested of the I counter, so that's the reason why I have generated this for loop. So if there are 10 items orders waiting in this Q1, I'm iterating from 0 to 9 to have all 10 orders. And what I'm doing then, I want to increase it by 1 because I assume that one order requests one item, one product. If this is not true, then you again have to implement in the order an order amount. And then instead of the ++, you have to link the order amount here. So if I, so this is not correct so far because I need here the parameter. This is perhaps then already something interesting because now we find the parameter due date here. So now this is position 7. And now outside we want to increase by 1. If I run it, I get a mistake that there is a type mismatch because I cannot convert double to int because I defined the parameter due date as double. And here it has to be an integer, which is not a problem because then I just cast it to an integer. Yeah, so that means all the decimals are deleted, and if there would stand 7.1 after the cast, it's a 7. So then we run it again. Then at least we get rid of this typo, and here it should be a semicolon, so no mistakes are there. I run it. Good. Now the question is, how can we see if that algorithm is doing what is intended? Yeah, most students stop now. I get crazy. There is no proof. There is no visualization, there are no tables, there is no analysis that what has been implemented is really working. So we need, so to speak, something for debugging. Yeah? So let's see how that is possible. I drag and drop an event, and I call it test. So that occurs once. That absolute time, I want it after 1 day. And then I want to see what's happening in my cross requirements. Yeah? So I run a for loop, int e is 0. My planning horizon is hard-coded to 7. That's the reason why I have here the backlog 1, 2, 3, 4, 5, 6, 7, 8. The backlog, this is the backlog, plus the planning horizon, 7 days. So, and yeah, of course, e smaller, e should be smaller than 7, and e plus plus. So, and what are we doing here? We want to see it on the console, system out dot println. So, and what are we printing? We are printing the cross requirements. At the position 0 for item A. And we want to see the whole planning horizon. So I want to have 8 values. If this is correct, we want to have 8 values, so it's 8. And we are running, yeah? So on this executed, this is the backlog. No cross requirements in period 1, no in 2, no in 3, no in 4, 5, 6, and in 7, in period 7, we have 1 cross requirement. That's at least a validation of what we have done. This is not the complete step of the MRP function cross requirements, because I don't have multi-items here. I just have a single item, and I also have just one production or one customer order. Yeah, so you can generate now 2, 3, 4 production orders, and you can verify if that is doing what it is intended, and then you can continue with the MRP steps as they are presented here. Netting lot size backward scheduling, then you do it on the same level. And if you have done it on the same level, so that means all sellable products, so item A and B, then you use the starting date of so after the MRP procedure, perhaps I find an MRP run here. Yeah, so the planned released become then the cross requirement for the child item. So that was our A item. So that means this line becomes the cross requirement for our X items. And then you continue with the second level of the MRP. And that can be beautifully implemented all in that model. And now, of course, you also have to model the production process. Yeah, so production process can then be modeled. Yeah, because we have not so far generated the production orders. We just yeah. So you have then perhaps here you copy here that one. That becomes then the cross requirements. They should become then netting. So the net requirements. Then you have, if I go back here, the inventory on hand, the scheduled receipts, the planned release, and the planned release. The scheduled receipts, you have to analyze it based on your simulation model. These are already production orders which are released into production and have started their production. So they have demanded the child items. So they are in the machine or in front of the machine. So you have to count them with an algorithm to define the scheduled receipts. You also have to count the inventory on hand so that we have this starting figure. Yeah. So this is just the academic example with a non-dynamic MRP for executing it one period. Yeah, so you have to make sure that you count every MRP period your new inventory on hand, and then you can start the netting. If you have calculate the cross requirements, if you have determined the scheduled receipts and the inventory on hand, then you can store the results in your matrix net requirements. And then you can use the lot size policy and calculate the planned receipts. And then the planned lead time in the backward scheduling to determine the planned release. And then you go to the next item on the same level. If that was the last item, you go to the next step in the bill of material. Yeah. So that should be the level, the minimum level of a design project in the field of logistics and production planning. This is the absolute minimum because what I'm interested in is here hybrid modeling, so that there is an optimizer included in the simulation, or that system dynamics and agent-based and or discrete event simulation methods are combined. So that should be just the outcome of the lecture simulation of logistics system as a foundation for your design or research project to have a nice work where academic relevance is present and where you can also satisfy some needs from industry. Good luck.